Hi everyone, this lesson is for geometry students. This is a last minute Lucy chapter 2 test review for geometry CPM. So let's get started and start reviewing. So first these are questions that you definitely will see on the test. If you have any questions, I would expect that you come into office hours for some help. Solve for the missing variable. So for the first problem here, we know that this angle here and this angle here, assuming that this line here is parallel, so I would have to say that those are parallel, then what that would mean is these two angles here and here would be alternate interior angles, and then therefore they're congruent. So I'm going to put my glasses on for this problem. It looks like this one is 3x plus 17, and then you would set that equal to 4 times x minus 3. So we have 3x plus 17 equals 4x minus 12, and you have to distribute there. I'm going to subtract 3x, and I get x. And then I'm going to add 12 to both sides, and I get 29 is equal to x. Now, notice that this is just it says the directions say solve for the missing variable. For this problem, x is 29. Please keep in mind that it is important that you be able to plug this value into the equation to make sure that A, you have the right answer because they do need to be equal, and B, that you are able to find an angle, like in case they ask you for this angle or that angle or another angle, maybe one that's supplementary to that as well. So I'm going to plug in 29. I'm going to get 3 times 29 is 87. So we have 3 times 29, that's 87. Add 17, so I'm going to add 17, and that's 104. So assuming that's 104, let's check this one right here. So 29 minus 3 would be 26. 26 times 4 is also 104. So these are congruent. We've verified our answer here. Just note, yes, I can ask you this vertical angle. I can also ask you, say, like, what's that angle? That's supplementary, right, to 104. Okay. In the right triangle shown below, this is a right triangle, what's the value of x plus y? Well, we know that the sum of the angles in any triangle is 180 degrees. And if this one is 90 already, then I can subtract 90 and make 90. What you should remember though is that once you take 90 out and it's actually a right triangle, this angle here and that angle there are complementary, which does mean that they add up to be 90. So basically, those two angles add up to be 90 degrees. For this problem here, it's asking me to label or to name the hypotenuse of this figure. Well, the hypotenuse is always opposite the right angle. So the hypotenuse would be line segment xy. Now, just a note, we usually use this line segment here to denote it being a segment or a part of a line. Just keep in mind that if I was ever talking about the measure of a line, like I wanted to say that xy, the measurement of that was like 10 inches or centimeters or whatever, you would not put a line segment above that. Okay, for this question right here, it says find the perimeter and area of the figure. And so the first thing that I would do is I think I would draw this line that came straight down here, and I actually did that. Because what that does is that shows me that that is actually a triangle and it's a right triangle. And therefore, that's going to give me the length of this side over here. So in doing that right there, in order to find the area first, I need to find all the lengths of the sides to find the perimeter. But to find the area, I just need length base times width for this shape. And I know that this is 16, so that's 12. And so 12 times 16, we've got 192. So I know that the area of this shape, this rectangle, is 192. So for the total area, right, we are going to add the area of this shape is basically adding that rectangle plus adding this triangle up here at the top. Okay, so that's our area. So this is, so far we've got 192 plus, and by the way, that's like, there's no units of measure on here, so I'm just going to say unit squared. For the triangle, though, the area of a triangle separately is 1/2 my base times my height. So 1/2 the base, and if I said this was my base, 10, what I need to remember is that, most importantly, that the base is always perpendicular to the height. That's absolutely, you have to know that. You have to memorize that, remember it, because a lot of times they're going to give you a third side and you might get confused as to, which one is my base, which is my height. If I turn it sideways, do I get a different value? The base and the height are going to be perpendicular, period. So far we know that. We don't know the height then. We need this height. That's 8 plus whatever this value is here. And that looks like it's 12, right? 8 plus 12 is, so the whole length is going to be 20. All right, let me erase that so it doesn't get any confusing. All right, so we know that this whole length is 20. So we're going to actually use the Pythagorean theorem to find the hypotenuse. So I'm going to go 20 squared plus 10 squared is equal to my hypotenuse squared. So I've got 400 plus 100 equals x squared. So x squared is going to equal to 500. So I need this, actually, I don't need this length to find the area, but I'm going to use that because I do want it to find the perimeter when I get to it. So let me finish this. So we've got x is equal to, I'm going to do 100 times 5. So square root of 100 times the square root of 5. So x is equal to 10 root 5. So that's our hypotenuse. Okay, so why is that important? Let me fix that. It's important because when I go around to find the perimeter, I need that. But to find the area, all I needed was the base and the height. So I've got 10 and I've got 20, and we're done with that. So half of, let's just say 10 is 5. 5 times 20 is 100. So the area of the triangle is 100. So 192 plus 100, right, is the area of the whole shape. So the area of the whole shape is going to be 292, and we're going to say units squared. Okay? Now, to find the perimeter, what I need to do is just add up all the sides. That's it. That's all I have to do with that. And now that we have this side here is 10 root 2, then we just add that up. So it looks like if I just start somewhere, I'm going to start right here. There I am. And so we're going to go to left. So we're going to go 16 plus 12 plus another 16 plus 8 plus 10, and then plus 10 root 5. So everything can be added together except for this 10 root 5, because only roots can be added with roots. Like 2 root 3 plus 3 root 3 would be 5 root 3. So you can add the same roots together, but you can't add roots with not roots. So I don't know. Let's see what we got here. Looks like we have 16 and 16. That's 32. I'm going to add 12. I've got 32 and 12 is 44, and we go plus 10 is 54, and then 8 is going to be 62. So it looks like that my perimeter is going to be 62 plus 10 root 5. And then when you do this, when you're like trying to write the answer, usually you put parentheses around this and then you say like units or something like that, because it's, these you can't add together. You have to definitely stay separate. For this problem here, we want to find the area of this rectangle. Now, I know that the area of this rectangle is going to be base times the height. And if it is a rectangle, then the bases, these right here, all the corners are, 90 degrees. You don't necessarily want to put a right angle here because it's not cut in half. It's not bisected. But what it is, if that's 90 degrees, is that's 60. So across from, remember 30, 60, 90 triangles, we did this in class. Let me review with you. If I have across from the 30 is 1, across from the 90, in 30, I'm just going to call that A instead of 1. Across from the 90 is twice whatever is across from the 30. And then across from the 60 degree angle is going to be A root 3. Okay, so what that means is here we go. Across from the 90 is equal to 2A. So that means A is 6. Well, A is across from the 30, right? It's this line across from the 30 degrees. So that means that's 6. And then across from the 60 degree angle is A root 3. Well, if A is 6, then this will be 6 root 3. And so to find the area, you're going to go base times height. So you're going to say 6 root 3 times 6. And the only thing for this that I would just make sure that you remembered is that numbers get multiplied with numbers. That's it. So 6 times 6, which is 36. And then the root 3 is just root 3, because realistically, there is actually a 1 in front of this root 3, okay, that we don't see or talk about. We just know it's there, right? So it's like 6 times 6 times 1 is what it really is. So here we go. So we have area is equal to 36 root 3. And no unit, so we're just going to call this unit squared because it's area. It's always squared. This is a parallelogram, and it looks like for sure you have to remember that when you're finding the area of a parallelogram, it is base times height. However, the base does have to be perpendicular to the height. And so we can't use this 8 for our height. This value right here is our height. That means because my base and my height have to be perpendicular, that means this value down here, that 20, is my base. That's my base. Now the height, I don't know, but I do know that this length is 8. And I'm going to redraw that like little triangle over there. What I want you to remember about this special right triangle is that it is a 45, 45, 90, okay? 45, 45, 90, because it has to be, if it's 45 degrees here and this is already a right triangle, that has to be a 90 degree, 45, 45, 90. So what we learned was that whatever this value is, that's the same value. So it'd go x, x, and this would go x root 2, okay? Now, if you already knew that this was 8, there is a shortcut method. Remember, we talked about that. 8, you would divide by 2 and then multiply by root 2, which would make this side 4 root 2, okay, which it is. But if you forget how to do the 45, 45, 90 special right triangle, you can always say, I don't know what that is, but I know it's the same as that. And I know that I can go x squared using Pythagorean theorem plus x squared is equal to my hypotenuse squared, which makes 2x squared equals 64. Divide by 2, I get x squared equals 32. And then I need to break down 32. Let me write it down here. X squared equals 32. Well, when I square root both sides, I get x equals the square root of 32. But remember to think perfect squares. Root 32 breaks down to root 16, right, times 2, root 2. And root 16 is 4, so that's 4. And then what I have left is root 2, so 4 root 2. So what we have is this length is 4 root 2, but this length, which is what I really needed for my height, 4 root 2, so that I can solve the problem. So let me erase some of this stuff, because ultimately what we're trying to do is find the area. We got a lot of stuff going on here. So the area is equal to my base, which is 20, times my height, which is 4 root 2. And again, I really can't make this, I really need to say this over and over again, I guess, but numbers get multiplied by numbers. So this 20 gets multiplied by that 4. The root, you can't touch it because you can only multiply roots with roots. So 20 times 4 is 80. So this is going to be 80 square root 2. And then whatever this value is, unit squared. If I don't have a unit, I just call it unit squared. Okay? So for this problem here, this is a trapezoid. And I want to find the area of this trapezoid. So I'm going to go find the area of that trapezoid. Area is equal to the height divided by 2 times the sum of the bases. And what that means is I don't know the height. The height's not there. So we're going to leave that blank for a minute. And we also know, we do know the bases. The bases are 15 plus 30. Now don't get this confused with this 12 out here, because that is not, it has nothing to do with what we're doing. So what we're going to do is, because this is 60 and we are assuming, we are going to just say that this is an isosceles triangle, because you have to have an isosceles trapezoid. 60 here, this is going to come straight down, which would then make this up here a 30-degree angle. Okay, so here we have a 30, 60, 90. There's my 90. Across from the 90 is 2a, which would mean a is 6. And what that means is A is across from the 30, so that would be 6. And then across from the 60 degrees is A root 3, which would be 6 root 3. And so that right there is the, from the special right triangle, 30, 60, 90, that's my height. So I'm going to put that in here as 6 root 3. So now we just have to simplify, and we've got this 2 will divide out with that 6. Remember, numbers get divided by numbers only. So that's going to be 3. So I've got 3 root 3 times, and that's 45, right? And then we're going to go 45 times 3. What is that? 45 times 3 is just 135. So my area is going to equal 135 root 3, because this 3 will get multiplied by that 45 only. And then this will be units squared. And so that's the area of that trapezoid. For this question here, they want to know if the numbers of the sides of my triangle would this actually be a triangle? Could this possibly be a triangle? Well, the rule is that the sum of two sides of a triangle, the sum of two sides has to be greater than the third side. And it could be any two sides, right? So we could go 7 plus 19. 7 plus 19 is 26, so that is greater than 25. 19 plus 25, definitely greater than 7, and 7 plus 25 bigger than 19. So they're just saying, yeah. And what they're asking is, can I make this a triangle? First of all, yes. And then second, is this a right triangle or not? So let's see. 7 squared plus 19 squared is what? To 25 squared. So let's do that. And yes, use a calculator. So 7 squared, that's just 49. And then we've got 19 squared and 361. And 361 add 49 is 410. So we've got 410 here is what value to 25 times 25, right? 625. Well, the hypotenuse, this value, the C value, which is this value here, the biggest value, is definitely greater than the other two sides. So then this is actually obtuse. It's not right. Okay. So this is saying, could this be a triangle, and could it be the sides of a triangle? So this one right here, this sure looks like a Pythagorean triplet. Remember the triplets? That would be 3, 4, and 5. And then most people see this 6, 8, 10 a lot, but that's just a multiple of the 3, 4, 5. The next triplet would be 5, 12, 13. There's a 7, 24, 25, and yes, there's an 8, 15, and 17, meaning 8 squared plus 15 squared does equal 17 squared. And so you can just verify all of that. We know this is 289, which is equal to 225 plus 64. 289 equals 289. So this one right here definitely is a right triangle. For this one, though, the 226, remember what I said about a triangle. Whether or not it's right or not, you still have to be able to add the two sides of a triangle to be greater than the third side. So like, yes, 6 plus 2 is 8, and that's bigger than 2. And 2 plus 6 is 8, and that's bigger than this 2. But if I can't add these two values up, which is 4, and make them bigger than this, there is no triangle for that problem. There's not a triangle. Okay. Now for this last one, which is the 3, 4, 5, this one right here is just definitely, it's a 3, 4, 5. It's a right triangle. It's a Pythagorean triplet. You can verify that by saying 3 squared plus 4 squared is equal to 25 squared, or 9 plus 16 equals, there I'm going, 25 squared. I was doing the other problem, wasn't I? Let's see. Equals 5 squared, and that's going to be 25. So 25 is equal to 25. Yes, it's a right triangle. The next question that you should know is given two parallel lines. So here's my two parallel lines. find the values of x and y. So these are my two values that they want me to find. What you first need to verify is that, hey, these are parallel, which means these are what we call alternate interior angles, and they are congruent, which means x is 70. So we know that x is equal to 70 degrees, okay? But we still need to find y, and what I do know is that the sum of the angles of a triangle is 180 degrees. So if you take 180 and you subtract 70, and then you subtract 65, you should get 45 degrees, right? So this angle is 45. Now, secondly, you also know that this makes a line like that, which means that that line adds up to be 180 degrees, right? So I could say 180 minus 70 minus 45, which is 65, right? Or I can just look at this and go, hey, my parallel lines are like that. And this right here, and then this angle right here, we call those corresponding angles, right? Corresponding. So those are congruent, therefore that's 65. For this one, find the missing legs, right? X, and this equals x root 2. Now I showed you another way. So like I showed you 3 ways to do this. The first way is to use Pythagorean theorem. The second way is to use the shortcut, and the shortcut is basically take 12, divide by 2, and multiply by root 2. And that third, the extra sides are 6 root 2. So I know that these are 6 root 2 because that's a little shortcut. But if you forgot how to do that, you can and you remember this part where you go, I know one's x, the other's x, and therefore this is going to be x root 2. If you just set that equal to x root 2 and then divide both sides by root 2, right? These cancel, and I've got x equals this. But the only problem with 12 over root 2 is that you definitely can't leave a root on the denominator. So what I would have to multiply by 1 in the form of root 2 over root 2. Whatever's on the denominator, that's what I'm multiplying by. Because root 2 times root 2 is root 4, which is 2. So I've got 2 on the denominator, and then on the top, I've got 12 times root 2. So think about it like this. 12 times root 2. Don't combine them. That's 12 root 2. So we have 12 root 2 divided by 2. So I ran out of room here. 12 root 2 divided by 2. 2 divides into 12, 6. 6 root 2. And that's what the side lengths. I just told you that. Okay, now the last thing is just using Pythagorean theorem. And that completely works for this because I don't know the sides. And both of the sides are actually the same value. So you could just go x squared plus x squared is equal to 12 squared. 2x squared equals 144. Divide by 2, I get x squared equals, what's that, 72? And then when I take the square root of 72, that's actually the square root of 36 times the square root of 2. Well, the square root of 36 is 6, so I've got 6 root 2. So we've got it done 3 different ways. You just have to pick the way that works the best actually for you. For this problem down below, our job is to, I'm going to make this a little bigger. Our job is to find, I guess, x, y, and z, okay? And so, first of all, I know this is 110. I know that's 110 because this is a straight line, and that looks like the word no. So, I'm really trying to work on my writing. 110. Okay, what else do I know? I know that's a right angle here, which means these two angles are complementary. So that has to be a 50. And if these are parallel, this C is parallel to D, right? I mean, it's a little frustrating. So if I know that this line is parallel to this line, then that means if this is 90, so is this, which would make Z 40, okay? So we know that Z equals 40. We know X is equal to 50. And then the only thing I have left is Y. And I mean, you know, Y. So I see something I want to show you. Check this out. This is kind of cool. What I want to show you is this. I know that these lines are parallel, which would mean this angle here is alternate interior angle with this angle here. You see that? Yeah. And so that means that that's 70 and that's 70, which means y would have to be 30 in order for that to be a 70. Yeah, I like that one. Okay, next problem. Find the missing lengths. So for this right here, you don't know this length, so we're going to use Pythagorean theorem. We're going to use side squared, right? Side squared plus side squared is equal to the hypotenuse. Remember, the hypotenuse is always opposite the right angle. And so we're going to go 2 root 5 quantity squared plus x squared is equal to 6 squared. So that's going to be 2 root 5 times 2 root 5 plus x squared equals 36. So 2 root 5 times 2 root 5 is 2 times 2, which is 4. And then root 5 times root 5 is root 25, which is 5. So 4 times 5 is 20. So 20 plus x squared is equal to 36. I'm going to subtract 20 from both sides, and I get 16. So x squared is equal to 16, which means that when I square root both sides, right, and you remember, x is going to equal to 4. And remember, and that's it for that problem. But like I said, I want to remind you of why this is happening. Why is the square root of x squared x? And the reason being, right, is a root is a half power. Remember, we talked about that. So realistically, I'm asking you to say x squared, which is in the middle, to the, it's a half power, 1 half power. The 2's cancel, right? And then you just get x. That's why the square root versus the x, they just cancel out. For this problem here, what we're looking at is basically using geometric means to find the values. You have to find x, y, and z. For some of these, you can use Pythagorean theorem, for sure, but I need 2 sides to use Pythagorean theorem. I don't know if any of these angles are 45, 45, 90s, which they aren't. I don't know if they're 45, 45, 90s, or if they're 30, 60, 90s. So we are at the mercy of Pythagorean theorem and our geometric mean formula, which we went over the other day, which says base is to height as height is to base. So that means that I would go 7 is to x, base is to height as height is to base. So 7 is to x as x is to 2. We're going to cross multiply. We get x squared equals 7 times 2, which is 14. We're going to square root both sides, and I get x is equal to the square root of 14. That's my height right here. That's what that is, the square root of 14. Okay, so now I've got x is equal to the square root of 14. And now what I need to do is, I'm going to erase all this, put root 14 in, put the square root of 14 in right here, and then simply use the Pythagorean theorem to find the other sides. So I'm going to go the square root of 14, and that's a squared plus b squared, right? Side squared, I'm going to do the left side. Side squared plus side squared equals my hypotenuse squared. So root 14 squared plus 7 squared equals y squared. So 14 plus 49 is equal to y squared. So 49 plus 14, what is that? 4, 5, 63. So y, okay, I'm running out of room again. Y is equal to the square root of 63. I'm going to move that down. Let me write that down. Y equals the square root of 63. I know I can reduce that. That's going to be root 9 times what? Root 7. Square root of 9 is 3, so that's actually 3 root 7. Okay? Now the last one would be to find z, and I would do it again, and I would say the square root of 14 squared plus leg squared plus leg squared, so plus 2 squared, which is 4, is equal to z squared. So 14, square root of 14 squared is 14. And then so I've got 14 plus 4, what's that, 18, is equal to z squared. So z squared is equal to 18. I'm going to square root both sides. I get z equals square root of 18. Again, the square root of 18, think perfect squares. That's going to be root 9 times root 2, right? So square root of 9 is 3. So z is going to equal 3 root 2. So we've got all our values here. That was a lot of work for that one problem. You probably won't see something as difficult as that, but definitely know your geometric mean, and your Pythagorean theorem. And remember, your geometric mean goes base is to height as height is to base. This question is just saying, hey, what's the largest supplement? That's all it's saying. You've got 4 different figures. We want to know which one has the largest supplement. So if you think about all the different values, you've got 180 minus 89. What is that? 91. You've got 102 from 180. That's going to give me 78. You've got 140 and 40 gives me 180. And then what is that? 176. Yeah, and 4 gives you 180. So which one's the largest supplement? A. Okay. What is the approximate length of a missing side of a right triangle? So I'm going to make a right triangle. I'm going to put it on my axis. I like to do that. I think that's good to know how to do that, especially when you're going into Algebra 2 next year. So here's my right triangle. It says that the hypotenuse is 16 and one side or leg is 15. So that means I've got to find one side or leg. Now I could have put 15 on the bottom. There's no reason I put it on the top. It's just where it went. So x squared, Pythagorean theorem, plus 15 squared equals 16 squared. I guess the hardest part of this problem is that you're looking at it and you're going, oh my gosh, it's a word problem. It's so hard. But realistically, not, right? So don't freak out when you see words. You know, you can just draw it. So we've got x squared plus 15 times 15 is 225. 16 times 16 is 256. So we're going to go 256, subtract 225. What's that? 31. I've got x squared equals 31. So x is equal to the square root of 31. Oh, I got to round to the nearest tenth. Now I need my calculator, like, for sure. So 31, calculator, second, okay, whoops. So figure out how to use your calculator with the root for sure. And we're going to get 5.67, what do I want to round to? To nearest tenths. So it goes tenths, hundredths, thousands. So tenths, that would be 5. So this is my answer. Oops. It's going to go like this. It's going to go x is equal to, let me fix this real quick. Just a note, because I'm taking an approximation, this is an exact value. Done. But most of the time you want to find an exact value. But if they ask you to round, this is about 5.5677. So what they want is the nearest tenth. So this is tenths here. So you look to the right, 5 or above, check. That means this 5 goes up. And so now x is approximately 5.6. And this is centimeters, so I'm going to write centimeters. Done. For this problem here, what we're doing is we are trying to find the value of x. We know that the sum of the angles in a triangle is 180 degrees, so we're just going to add them up. We're going to go 3x plus 2x plus 1 plus x plus 5 adds up to be 180 degrees. We've got 3, 4, 5, 6 x's, so 6x plus 6 equals 180. I'm going to go 180 minus 6. That's going to give you 174. But I want you to divide 174 divided by 6. And 174 divided by 6 is 29. So x equals 29. Now, here's the thing, especially on a problem like this. They're done. They're like, there you go. X is 29. However, the one thing, and by the way, I know you guys are used to boxing things up, and it makes it so much clearer for us, for me anyways, to teach with that boxed up. But I do want to say that the correct way to actually write this answer, and I do hope that you guys start writing these correctly, is to put this in, say x is equal to a solution set, because this is an equation, and the solution set, that's how you write the answer. And if you want to box that up after you put it in a solution set, I would love that. Okay, just saying. Okay, and you do that whenever you see an equation. So what was I saying? I was saying that 29, I got to plug that back in. I know this is only saying find x. And I know, time-wise, we're conscious of time. I'm going to be respectful of that. But at the same time, you guys have got to know how to find an angle, right? So like this is 29, add 5. So that's just going to be 34 degrees. So that corner here, see, the measure of angle C is 34 degrees. Yeah, you're going to need to know that. And then this is 3 times 29, right? So 29 times 3. Oops, that's not right. 29 times 3, I got 87. So this is 87. And that's that angle. So I'd say the measure of angle A is equal to 87 degrees. Like, you have to know how to write these too. Lastly, this is B up here, and you would say the measure of angle B is equal to, and then you would say 29 times 2, right? That's going to be 58, and then you're going to add 1, so that's 59 degrees. So you'd say that's 59 degrees. Done. For this problem here, this is saying, hey, find the missing measurement. This is the height. We know it's the parallelogram. We know that the area of a parallelogram is equal to the base times the height, where the base is perpendicular to the height. Now, if my base is 6, I still don't know the height. The height's unknown. But my area actually is 12. Okay, so I'm just going to divide by 6. I get the height is equal to 2. And remember, area is units squared, whereas, sides, height, that kind of thing, those are just units. And so this is 2, what's my unit? Kilometers, km. Okay. This one is saying solve the system of equations for x and y. Now, in the previous video that we went over for the chapter test, not the last minute Lucy review, but the actual chapter test review that we did in class, which we may or may not have finished. I talked about all the different ways to solve a system. We talked about the graphing method. We talked about elimination, and we talked about substitution. For this problem, if you want to use substitution, you would solve for x or y. And for me, my choice would be to solve for x, move this 3y to the other side. So it'd be negative 3y minus 9. And then I would take this and substitute it right there in for x. And I'm going to do that right now. We've got 2 times x. X is this, negative 3y minus 9. And then minus y equals 10. So distributing, that makes negative 6y minus 18 minus y equals 10. Negative 6 and negative 1 is negative 7y. And then I'm going to add 18 to both sides. And when I do that, I get 28. So that means y is equal to negative 4 when I divide by negative 7. Don't box that up, because when you're asked to solve a system, this right here, when you're asked to solve a system, the only thing that you're actually looking for is the intersection point. That's it. That's what you're looking for. And an intersection point is a point. It's like x, y, okay? So we found y. Y is negative 4. Okay, so now we got to find x. So I'm going to take what y is, and I'm going to plug it back into another equation. So I'm going to go x is equal to negative 3 times y, which is negative 4, and then subtract 9. So that looks like it's 12 minus 9, which is 3. So that would be my point of intersection, and that is how you solve a system by substitution. Okay, and so just note, I would then like pick another equation, like 3 plus 3 times y, which is negative 4. What is that? 3 minus 12, is that negative 9? Yeah. Okay, now the only thing that I want to do right here is, just for fun and just for a little bit of review, solve this by elimination. And in doing that, just very quickly, I would multiply the top equation by 3, because I already have the bottom as positive 3, and then when I multiply the top by 3, that's going to be a negative. So distributing, I get 6x, 3 times negative y is negative 3y, and that's 30. And when I add these up, these y's are going to cancel, and I get 7x is equal to, this is 21, x is equal to 3. And that's this value here. And then I would, of course, plug it back in to get y equal to negative 4. But I just want you to be aware that there's more than one way to solve these systems. And then there's the graphing method, too, which we didn't do. Area is, this is a rectangle. So the area of a rectangle is equal to base times height. We already know that the base and the height are perpendicular. So the base, pick one. Pick one. I'm going to say the base is, I don't know. So we're going to go x times the height. I'll say the height is 9.2, and just say times like that. Area is here. They gave me that value, 75.4. And so in order to find x, which happens to be my base, I'm going to divide both sides by 9.2. And in doing that, what do we get? We get 75.4 divided by 9.2. And that is approximately, oh, here we go. Round your answer to the nearest tenth. So the answer I got was 8.1956. And by the way, these become abouts, like little swigglies. The answer, if they asked me to round to the nearest tenth, right? Let me do it this way. X is about like that. The nearest tenth, it goes tenths, hundreds, thousands, right? 10,000s. So if I'm looking at if I'm rounding to the nearest tenth, that's this value. You have to look to the right. Yes, is that 5 or above? Check. That means this number goes up 1. So now we're at 8.2. And my units is inches. I'm looking for a side. So it's just inches. It's not inches squared because area is inches squared. Now, if you're somebody who has to write out, like, see how you can see up here, I didn't put any of the, inches squared in there. But if you need that, you should do that. Given parallel lines, here's my parallel lines, cut by transversal. What are my corresponding angles? They are congruent. Corresponding angles are congruent. Do not get corresponding angles confused with complementary angles. So many people get that confused. Complementary angles, you guys, add up, are two angles that add up to 90. Corresponding angles are angles that are congruent because they are formed from parallel lines. Almost done here. We just have 2 more slides. We have find the area of this trapezoid. Remember, area of a trapezoid is going to be height divided by 2 times the sum of the bases. So we've got 5 divided by 2 times 3.2, and that looks like 9.2. So what's 9.2 and 3.2? Looks like 2.4, so 12.4, and that equals my area. So my area is going to equal 12.4 divided by 2, which is 6.2, right? And then we've got 6.2, so 6.2 times 5, and I get 31. So my area is equal to 31 kilometers squared. This one here is a triangle. And by the way, be careful with this. I know a lot of, you got all these, okay, this is not a right triangle. A lot of kids look at this and they go, is that the right triangle? No, that is not the angle. That is not it. Okay, the actual triangle, okay, is this right here. That's the triangle that they're talking about right there. So once you see that that's actually the triangle, then you should be okay. So area is equal to 1/2 the base times the height, where the base is perpendicular to the height. Period. This height right here is the height of my triangle, okay? It's just moved outside, but it is actually the height of my triangle, okay? Even though my height is not inside my triangle, that is okay. So we're going to go 1/2 my base. My base is 4 centimeters. My height is 4.1 centimeters. And so I'm going to go 1/2 of 4 is 2. 2 times 4.1 is 8.2. So it looks like that my area of my triangle is going to be 8.2. And this is going to be centimeters squared. Okay. This one right here is just given the pyramid below, which lines are skew. So just name a couple of skew lines. We're talking about, remember, skew lines are lines that are not in a plane. Okay? So like if I have parallel lines have to be in a plane, no matter what. If I have intersecting lines have to both be in that plane. You cannot have this line here parallel to this line out here if it's not in that plane. Parallel lines have to be in the same plane. Intersecting lines have to be in the same plane. Perpendicular lines they definitely have to be in the same plane, but I actually could have them like protruding. But anyway, enough said with that. What I wanted to say is skew lines are lines that are not in the same plane and that are never going to touch. So if I'm talking about this plane here, and I'm talking about this line here, this line is going to touch right there. So those are not skew. So if I'm talking about skew lines, then it says which lines are skewed. So I could say this line here and this line here on top that let me use the other line. They are never going to touch, like this one right here. That line here is never going to touch this line down here. They're never going to touch. So those would be skew lines. Two parallel lines lie in exactly one plane. True. Same side interior angles can be congruent and supplementary. Well, we know that same side interior angles are for sure supplementary, right? But the only way that same side interior angles can be congruent is one way, and that's the only way, is if the two parallel lines are cut by a transversal that's perpendicular, because that would make all of these right angles, and then that would make my same side interior angles congruent and supplementary. So this is a true statement. A transversal can intersect two coplanar lines. Coplanar means that they're in the same plane. Yes, we want that. A transversal, here's my transversal. Wait, those are my lines. There's my transversal. Can intersect two coplanar lines at the same point. Oh, so these two coplanar lines, they're in the same plane. They don't have to be parallel. It didn't say they were parallel. So let's say I have a big plane, and I've got two lines at my transversal intersecting the two lines at the same. I'm going to say there's my two lines, and my two lines are already intersecting. So yeah, they can intersect at the same point. Yes. If it's drawn like that. Now, it can't intersect them if they're parallel, right? Okay. And last question, actually. Which one of these has the greatest area? Well, the greatest area, this one, half base times sine. Let's just do, I think we have to do each one of these. So in order to do this, we're going to go triangle. So that's 1/2 my base times my height. So 10 times 9. Note to self, right? They are going to give you extra information. So like this 15, we're not even using. We would use that for like perimeter, but not. Okay, so for this one here, so that's 45. This one is a parallelogram, which is base times height. So that's base, height is 12. Okay, right? Remember, you guys, the base and the height have to be perpendicular. Okay, so we've got the base is 19 times my height, which is 12, not 15. Another information I don't need to know. 19 times 15 is 285. We'll go units squared. Let me erase this so that you guys can actually see what I just did. Okay, that 15, just FYI, is a side. Okay, all right, and then this one, so that's 285. 12 times, oops, oh, that's not right. That's not right. Hold on. 19 times 12 is 228. Okay, see, who says calculators are always right? Right? 228. Okay, lastly, you've got, that's a trapezoid. So we've got height divided by 2 times the sum of the bases. Sum of the bases are 28 plus 13. Okay, here's the thing with that. That's 41. So I've got height times 41 divided by 2. I don't have a height, but oh boy, there's my height, right? I noticed that this is a right triangle. I don't know this, although I do know it. It's 6, 8, 10, right? It's a Pythagorean triplet. Remember the triplets? 3, 4, 5. If I multiplied a 3, 4, 5 by 2, it'd be a 6, 8, 10. That's where that came from. Okay, that's 8. And so we're going to replace this height with 8. So we have 8 divided by 2, which is 4. And then 4 times 41, right? 41 times 4 is 164. So, yep, definitely looks like that our mild manner parallelogram over here wins. So, good luck on your Chapter 2 exam. I have great hope that you, and assurance, if you're watching these videos, you're going to do a lot better than if you didn't. And I know you're going to be successful. I do want to say a few things just in closing. Please remember, this is a Last Minute Lucy video. I'm hoping you're watching this. I'm actually going to send this to you to make sure throw that back at you. You have to use Chrome when you're Chrome. You have to use Chrome when you're taking the test on Canvas. Okay, definitely if you're not using a Chrome browser, then you may not see some of the pictures that are on the test. So, and then if you don't see the pictures, that's just the way it's going to be. Additionally, you're going to have to upload your test questions, your answers. You're going to have to upload that as a PDF file to the question that it asks you to. And for that question, you can only upload one file. That's it. If you upload more, it's not going to and you're not going to be emailing them to me. You're going to have to actually try to do that yourself. And lastly, I think just watch your time. This is really important because you're going to have a certain amount of time to take this test, and you really need to be on it. So I wish you the best of luck, and thanks so much for watching. Really a smart move. Thanks for watching.